Isomers. What are isomers? Same molecular formula but different chemical properties. That is what they are. They're compounds with the same molecular formula but different chemical properties, meaning that if you have CH5H12, the next one will be shaped differently, but it will be CH5H12 as well. What not to do when asked to give the isomer of any particular long chain hydrocarbon? Let's use pentane, C5H12 as an example. We have here 5 C's, 5 carbons, and 12 H's. Pentane. Mm, what not to do? Don't bend the chain and call it an isomer because it is not. Because if this is your longest chain here, right, then bending it only makes it a bent chain. There's nothing different about it. And this is the same thing. It's a bent chain here, and it's a bent chain here. There's nothing different about it. There was no taking out of a part of it and moving it around, right? Because if I were to put my hydrogens in, it'll be the same thing, right? And always remember that when you're putting in your hydrogens, make sure that your bonds surrounding are always 4. For example, the second thing you're not supposed to do is to cyclize your chains. Why? Because when you do that, you end up with a different molecular formula, right? And what I was saying with the 4 bonds is that you have 1, 2, 3, 4 that carbons attached to. Now, when you cyclize your chains, you end up having a formula where instead of having CnH2n plus 2, like you had for pentane, because that's the general formula for alkanes, you end up with a formula of CnH2n, right? And so you lose 2 hydrogens, and you can see that here, if you count them, if you put your hydrogens in, you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So don't cyclize your long chain hydrocarbon because you're going to end up with an incorrect molecular formula. So those are the 2 major things you're not supposed to. What you must think of, what you must think of is your chains as Legos, right? So imagine you have Legos, little pieces that can be moved about. If you look at the above as a simulation of a carbon chain, you get a rearrangement like the following. So this is a different movement going on here. Because if you move these, if you move this in between here, or move this outside, it's still a long chain hydrocarbon, same as above. So back to C5H12. This is your longest chain, 1, 2, 3, 4, 5. It's the longest chain, and you can also say 1, 2, 3, 4, 5 from the next side, right? Once it's like this. Now, drawing possible isomers, remember the molecular formula of the isomer must be the same as the original formula, right? So if you were trying to draw a molecular formula for pentane, you have 1, 2, 3, 4, and this is your 5th carbon up here. And I took out the H's so you can see how to change up your chain. So 1, 2, 3, 4 is your longest chain now, and this is like a group. This is a group on your chain, so it's now branched, right? Now doing this, drawing this and drawing this are the same thing, because whenever you have groups attached to your carbon chain, you give it the lowest possible number you can give it. So from start, if it was from starting from 1, this would be 2 right here, 3 and 4, and that would be the lowest possible number. If you started from here and said 1, 2, 3, this would be incorrect because this 3 is a higher number than 2, right? So you must always give your group the lowest possible number that you can give it. Drawing it the other way, as I said, is the same thing because you have 1, 2 is on carbon number 2. You don't start counting from here to give it a 3 number because that will be incorrect because 3 is higher than 2. So drawing it that way is the same thing. And this way is also the same thing. It might be a little bit tricky, but what you would have to do is look for your longest chain. So usually I would tell my students to count from any end. Any end, you have an end here, you have an end here, and you have an end here. You can start saying 1, 2, 3, 4. That's 4. 1, 2, 3, 4. So now you know that you have the same amount of carbons going in either direction, right? So therefore, if you have that, one of these must be a group, and you could always rewrite it as a flat long chain to make your life easier. Say we say this is for this one, and this is this, and therefore we know we have a group here somewhere, and we just flatten out our chain, continue flattening out, right? So we have 1, 2, 3, 4. So you notice it's the same as this, same thing. And now you would just number it 1, 2 to give it the lowest number, and then you fill in your hydrogens accordingly. So you put your, make sure you count your hydrogens, 1, 1, 2, 3, and you make sure you count your bonds. So 3 hydrogens and this extra bond. See, that gives it's 4 bonds. This has 3 bonds. This has, sorry, this has 3 hydrogens and 4 bonds. 1, 2, 3 hydrogens and 4 bonds. 1, 2, 3 hydrogens and 4 bonds. And this is also a form of branching. So you count your longest chain, 1, 2, 3, 1, 2, 3, or it could be 1, 2, 3, or 1, 2, 3. You realize that this is central. It doesn't change number, so you can take your chain going this way or going this way. And I usually like to do it this way, and I would say this is one group here, and this is one group here. Right? So therefore I have 2 groups attached to one carbon atom labeled as the number 2 tag, right? Which is pretty good. So treasure the hexane on your own and let me know how many isomers it has. Don't forget to subscribe and comment. Hello. In the next video, I'll be doing the naming of these compounds so that you get a gist of how to name these compounds on your own in your spare time. You realize that it's pretty easy with time and practice.